we'll start off like this. And let's do it this way. We always do it the other way. Let's do it this way. Here's, let's call it theta. This is indeed a right angle. Let's call this y. Let's call this x. I always do y and x. Let's call this A, and let's call this one B. Now, what I want is give me A in terms of theta. Ooh, this is important here. If we didn't have this right there, yeah. But if that's a 1, if the hypotenuse is a 1, then A is equal to?
Cosine. Cosine of theta.
It should be cosine theta. And the way I'm going to check that is to just go, well, wait a second. Cosine theta is just adjacent over hypotenuse. It's just over 1. And so then, yes, over 1 is the same thing as just the thing itself. So this is cosine theta. In other words, that length right there is cosine theta. Can we all agree with that? That's cosine theta.
Yeah.
Now what about B? B is equal to what?
Sine.
Sine theta, right? By the exact same reasoning. I'm not going to go through it. It's just sine theta. And if it were something else, if it were x, then that would be the length cosine x. That would be the length sine x. And if it were something even more exotic, something like, oh, I don't know, a plus b, then this would be what?
Sine A plus B cosine.
Yeah, a plus b cosine a plus b, right? Just whatever that angle happens to be. And if it's just the sum of two numbers, well then that's just what it is. Is everybody with me on that? Does everybody believe that? Why do you always take your socks off? What is up with that? Aren't you cold? Sorry, it's cold in here. The heater's broken or something. I can't get it going. So that's just too bad. Everybody with me on that? Everybody follow? Any questions? Do you believe it?
Yes.
Okay, so this is where we're going to start. And another nifty little fact we're going to need today. Suppose I have two parallel lines. Those lines are parallel. And I draw any line, boom, going through there. Do you believe that this angle is the same as that angle? Right, and it kind of has to be. And the way I imagine it, to see if it's true, is, well, if it were straight up, then they would both be 90, right? The one on this side would be 90, the one on this side would be 90. And if I move it over 1 degree, I've lost a degree over here, and I've also lost a degree over here. Now there's another way we could prove this, actually, or we could show more rigorously that this is true. If I go horizontally here, here. And let's give this angle a name. Let's call it theta. My claim, and actually we don't know, this is what we're trying to show. We don't know if this is indeed the same. So I'm just going to put a question mark. Like, I don't know what angle that is. But one thing I can tell you is, since this is a straight line, and since this is perpendicular to that, then these two angles add up to how many degrees? 90, right? So it must be that phi plus theta is equal to 90.
Oh,
yeah? And now, if you have the interior angles, that plus that must be what?
90.
Yeah, because, right? Because, like, of course, the sum of them all is 180. So you could say phi plus the unknown plus the 90 that you have right there is 180. Subtract the 90 over, and you have phi plus your unknown is equal to 90. It'd be much easier to just think, well, if one of them's right, then those two sum to 90. And if that's the case, then it must be that your unknown is the same thing as 90 minus phi. But we could say, well, wait a second, 90 minus phi is just theta. So it must be the case that that is also theta. Okay? Everybody with me on that? Everybody buy that? You probably did something like this in geometry. And maybe just for fun, you know, and you're like, man, I'm bored. I want to see something about angles. And so you start doing that. You guys don't do that? I do that all the time. Okay. All right, we're done. So, this is what we're going into today. What I want are formulas or identities for these two bits, given any A and any B. What is sine A plus B. Can we write that in terms of sines and cosines, or maybe tans and cotanes, whatever? Ditto with cosine.
So it's just like what we do with logarithms, where it's like if it's like log of A times B, we can write it as
Yeah, there's a way of, exactly, because now there's a way, like we have with logarithms, which is a good point. So you have any logarithm, and you have a formula that says if you have A times B, that's the same thing as log A plus log B, right? And as we see, you might say, why would you want to do that? But then we've seen how nifty this becomes, right? Like this could really make your life easier to go from one side to the other, and vice versa, right? Ditto here. We're going to find that your life could be made so much easier if we could find a way. Now, instead of multiplication going over to addition, remember the dual of this was this right here, was that. Right? That's what that is where this property comes from, right? Is that addition goes over to multiplication. Here, multiplication went over to addition. And now it's not so simple. It's not as simple as this. We don't have a nice simple rule. We're going to have to derive what this relationship is. But thank you for bringing that up, because this is what's really motivating this. Is like, why would we want a formula for this? Why does it matter? Well, because it could make your lives much, much, much easier. And so this is what we're going to do. I'm going to start off like this. I'm going to make a line segment with length 1. I want it to be a bit steeper than that. Sorry. Line segment of unit length. Length 1, right there. Now what I'm going to do, I'm going to go draw horizontal this way. Okay. And I'm going to do this. We are going to use this picture that I'm drawing to derive a formula for these guys right here. So it looks like I'm going to need an A and a B. So how about I let this be A right here. That angle is A. This angle is B. What I'm going to do is now draw this guy straight down like that, and there's my right angle. Okay? Everybody with me so far? Now, I'm going to stop for a second. Because what we're about to do, if you'll notice what I'm setting up here, this assumes that by this picture right here that I'm drawing, A and B, not only do they have to be less than 90, but A plus B has to be less than 90.
Yeah.
What we're going to derive will work for any values, no matter how big or how small, whether they're negative or whatever. But our proof that we're doing right here will not cover that. Our proof here is just going to cover this special case where they're small. Your book does it in general. Your book in section 7.3 takes care of the general case. But I didn't want to just do the general case because you could just do it in your book. This is a completely different way of going about getting these formulas. And so what we could do is just kind of derive these and say, if you believe it, they work for other ones. If you don't believe it, you could look in your book and see the rigorous justification for all of this. So, but I wanted to show you something that wasn't in your book. And I like this way, actually. This way is really cool. So I'm going to draw a straight line across here. Straight line going up. Now, let's see. Since this is horizontal and this is vertical, this is a 90-degree angle. Ditto over here. Everybody with me?
Yeah.
Now, there's a bunch of other angles that we don't have written. It turns out we're only going to need 2 of them. And if you'll notice how I set this up, what we just talked about, this is a straight line, these are 2 parallel lines, so this bit right here must be what?
Wait, no, A plus B.
A plus B, right? We're kind of thinking about this line, the length of length 1. If one angle is A and the other one is B, then this is whatever A plus B is, right? Like from here all the way to the 1. Which means that this right here is also A plus B. Everybody buy that? Objections? Questions? Everybody with me on that one? Okay, we're really only going to need one other angle here. And it's this guy. How can we figure out what that is? Well, one thing.
Oh, wait, no.
One thing I notice is that from here all the way to here is 180 degrees. Right? That's a straight line from here all the way to there. So I could say, I don't know what this is, so I'm going to call it theta. I don't know what this is, I'm going to call it phi. But I could tell you that that plus that is 180. So theta plus 90 plus phi is 180. Subtract off the 90 and I get theta plus phi is 90. But check this out. What's that plus that? Wait. This is a right triangle.
90.
So that's 90. And so A equals 90 minus phi. 90 minus phi is equal to theta, which is the one that we want. 90 minus phi is equal to theta. 90 minus phi is equal to A. So there's A right here. Okay?
Weird.
Yeah, I know. Yeah. When I first saw this, I was like, what? How could that be A? And like, it just said, it doesn't show how it was derived. It just is a picture that looks like this. And you're like, how did you get that? Oh, it's interesting. Why do you take your socks off? Okay, so here's the thing. How's this going to help us get this? Well, let's just see. Think about this. Sine A plus B would be opposite over 1, right?
Yeah.
And we just did this, right? This length from here to here should be sine A plus B. Right? And let's just make sure of that, right? Here's whatever angle, here's 1, and if I say sine A plus B, that's going to be my opposite, right? There's my opposite over hypotenuse, right? Hypotenuse is equal to 1, opposite is that length, that's that length, right? So that means that this length from here to here is what?
Wait, from where to where?
This little bit right here.
Cosine.
That's cosine what?
A plus B.
A plus B. And those are the things that we want. So now let's look at this. And here's the idea. Is that notice that this length from here to here, which is the thing that we want, is the same as this length from here to here, which is this bit plus this bit. Right?
Yeah.
Yeah? And and if that's like, if you don't really buy that, if you just imagine this triangle. If I just drew this triangle right here and said that's the length A plus B, right? And I guess that would be if I dropped one straight down this way. That's what we'd have right here. And you'd say, well, if that's 1, then this length right here would be sine A plus B. That's what we're looking for. That height is the same as that height right there, which is the same as that height. And so, yeah. Okay. So, sine A plus B is going to be whatever this distance is plus this distance right here.
And you can find.
Cosine A plus B, on the other hand, would be what you get if you take this distance and subtract off this distance right there. If you subtract that off, if you take this bottom right here, subtract that off, then whatever's left over will be the same length as that guy right there. Everybody buy that?
Yeah.
Do you buy that, young man? Okay, good. Okay, so now all we gotta do is just find these 4 lengths. We need this length, this length, this length, and this length. In order to start though, what's really gonna be helpful is if I could find this length and that length.
Yeah. Well, we can.
And so in terms of B, what's that length? It's a right triangle. This is the first problem we did. It's just a little wonky, right? If this is B and that's 1, this is why we're using this one first, because it has 1.
Yep.
And so then what's this length right here in terms of B?
Cosine. Oh. Sine. Yes.
Sine, because opposite over 1
Back.
is sine B. There's sine B. And then that means that this one is what?
Cosine.
Cosine. Cosine B. So I'm going to label these right here. This length is cosine B. This length here is sine B. Here's your socks. Are you reaching for your sock? Here. Here. Okay, whatever. Okay, so now we could get this length and this length. Now, it'll be in terms of cosine B. Cosine B is going to show up. But let's just think about this, right? So if that's A, and if this, let's call it Y, and we know that this is cosine B, then we could say, what relates these guys together? Which trig function? Sine of A equals what over what?
Y over cosine.
Y over cosine B, which means that Y is equal to what?
Cosine of B times sine of A.
Right, bring it up. So we have sine A, cosine B. And so, which one did we do? We did that one. This one is sine A, cosine B, right there. That's that length from here to here. Okay, what about this one?
What would be...
Because if we now we're trying to find the x, and so we have what relates these guys together? These three?
Cosine.
So cosine of what equals what?
Of A equals x over cosine of B.
X over cosine B. And so x is equal to what?
Cosine of B times cosine of A.
A cosine B. So this length is cosine A, cosine B. Okay, that's that length right there. Everybody believe this so far? Am I going too fast? No? Okay, good. We just have two more lengths to get. We're going to do the exact same thing. Now, the triangle we're working with is this one. I'm going to go ahead and, because this is how I like to think about it, right? I'm going to reorient it that way. And what's the hypotenuse again? Wait, that's the only length we have up there.
Sine of B.
Sine of B. And so this length is what?
Sine of A.
Yeah, I think so.
Equals
So
y.
sine of A is equal to what over what?
Y over sine of B. So sine of A times sine of B. No, Y over sine of B.
Sine of B, there we go. And so that y equals sine A sine B. Did I do that right?
Yeah.
Yeah? No. This length. Yes, y. Yes, because I rotated it. Yeah. That length, right, is this one right here. There's my y. Yeah? Okay. All right, there. So now that length, from here to here, we said is sine A sine B. Right? Because I rotated it. And so probably shouldn't have rotated it. Let's do the next one not rotated, just to check ourselves here. Okay. So there's that. There's A. There's that. And now we want this length, knowing that this length is sine B. How do I get that length with respect to that angle?
Cosine.
Cosine of what is equal to what?
A equals like x over
The length that we're looking for over what?
sine of B.
Sine B. So then that length is equal to what?
Cosine A sine B.
Cosine A
Do we already have that? No, we didn't.
sine B. Okay. So I'm going to write it as sine B cosine A. This is sine B cosine A right there. So that's that length right there. So sine B cosine A. Therefore, this is what we're looking for, finally. We get that sine of A plus B is that one plus that one. So sine A cosine B plus sine B cosine A. Huh. I'll be. And now we said that this length was the big length minus the small length. So that would be cosine A cosine B minus sine A sine B. I'm going to have to erase a little bit here, but we remember how we got it. Sine A sine B. Now, to be clear, we've only proven this for two angles whose sum is smaller than 90 degrees. Otherwise, this would look much different if one of them came up to here and the other one came down to here. Your book deals with that and does a very good job. So if you want a rigorous justification for that, look at your book. Otherwise, this is a good way of doing it. And if you believe me, it works no matter what size these angles are. It could be like 9 pi, where it's ripped around 9 times, or I guess 4.5 times, and etc. Right? One thing we can do, though, is notice. So this is what happens when you add them together. What if we subtracted them? So I'm gonna get rid of this picture right here. Can I get rid of this picture?
Oh, yes.
So one thing we could do is say if you're subtracting two angles from each other. So I'm gonna rewrite one of these real quick. So how about sine A? We know that sine A plus B is equal to sine A cos B plus sine B cos A. Okay. Now, if it were minus, though, that would be the same thing as if I added a negative b, which would just be the same thing as putting a negative in here and a negative in here. Does everybody believe that?
Yeah.
Okay, so in other words, what I'm saying is if my original problem were what is sine A minus b, I could say that's the same thing as sine A plus negative b. And sine anything plus anything should work out like this. And so if it's a negative b, I'll just plug in a negative. But cosine
Of negative b
is equal to what?
cosine of b.
Just plain old cosine b, right? Do you think about it as you pull the negative out and it stays positive because this thing
Sine
is
of
even. So
A
this
plus
is going to
B
be sine of
equals
A
sine of a minus b.
cosine b. But what about sine minus b?
Oh. Is negative sine of b.
Is negative sine of b. So I pull out the negative here and I have minus sine b cosine A. So then, in other words, notice this. Notice what's happening here. If it's a minus in there, it's a minus between these two bits. If it's a plus in there, it's a plus between the two bits. So we could knock this out all at once in one nifty little formula, and you're going to see this a lot, is that I'm going to go plus minus is plus minus. So in other words, if it's plus on the, whatever it is on the top, you do the top one. Whatever it is on the bottom, you do the bottom one. Let's do the same thing for cosine. See what happens. Can you guess what's going to happen? Can you guess what's going to happen? Cosine A minus B is the same thing as cosine A plus negative B, which is, let's see, cosine A cosine negative B. Right? I'm just using this formula, minus sine A sine negative B. Again, I'm going to get you in just a minute. So then if I pull out the negative, cosine is an even function, so it's the same thing as just plain old cosine B. Pull out the negative from here, that makes this positive. Check me on that. Is that true?
Yeah. So it's just always.
So it's just opposite. It's opposite of this. So when it's plus here, it's minus here. When it's minus here, it's plus here. And you'll see this often when you have formulas, especially like if you look on Wikipedia or something that has a big, huge thing of formulas. You'll see this plus minus minus plus thing. And all that means is that whatever's on the top, right, or like if the thing you're working with is something plus something, then that one's on the top, so I do whatever the top one says. So this one's plus, that's on the top, and so I do the minus.
But what if A is negative?
Well, then you'd have to rewrite it.
Oh, you could write it as
B minus A. Yeah. And so, then that's the thing. Otherwise it would be, or if they're both minus, well then you just have a minus minus and you know how to deal with that. If everything's minus, you either pull it out and make it negative with sine, or you pull it out and it stays positive with cosine.
Yeah.
So, good question. Good question.
Or you could factor out the negative at the start. Like if it was minus minus.
If they were, exactly, that's what I'm saying. That's what I'm saying. So like if you had something like this, like cosine negative pi minus pi over 2, you'd say, well, that's the same thing as cosine minus positive pi plus pi over 2.
And then the minus goes.
And then the minus doesn't matter, so you say cosine just whatever. And so now you have this. Although this one's easy, pi and pi, you could just add them together and do it. It would be what, 3 pi over 2? Cosine 3 pi over 2 should be 0. So anyway, but yeah, because I used a contrived example. Okay, so let me get this guy. Come here, guy. Come here. Hey. Oh, buddy. All right. Barefoot. Barefoot is like 50 degrees in here. All right. Get your arm through. Okay, so questions on this? What we're about to, in trig now, we are about to embark upon what I call formula hell. We are going to have formula after formula after formula, and it's going to get crazy, okay? So, but the thing is, there are only a few of them that you really need to commit to memory. This is one of them. These, like, if you could keep this straight in your head, you are going to be in really good shape. Okay? I would suggest that you commit this to memory. Okay? Like, really commit it to memory. Don't forget this one. There's a more important one that we'll talk about when we come back from break. But this one's probably the second most important. Well, of course, sine squared plus cosine squared is 1. That's like, yeah, that one is the most fundamental.
That one's very easy to remember. So.
Okay, so now a couple things I want to say. There's a mnemonic. It's really easy. You know that both of them look like this on the left-hand side. One of the hard things to keep straight is which one was the plus minus and which one was the minus plus. The mnemonic I have in my head is that sine is the same. Sine is the same, meaning that cosine's opposite. Okay, that's one thing. You'll also notice that sine has this nice pattern. It goes sine, cos, sine, cos. Cosine just doesn't do that. It goes cos, cos, sine, sine.
Well, it goes AB, AB.
And the way that and the way that I've done it, and you see, like, you'll often see this as sine A, cos B, cos A, sine B. I prefer to do it this way because it helps me remember, wait a minute, sines, so first off, sine's the same, and sine is also, well, I'm not going to try to do that. So, sine is the same, and I know that sine's the one that goes sine, cos. The other one goes cos, sine. And this way, right, obviously you do AB, and if you have it written this way, AB in both cases, and then you just BA backwards, right? This one's AB, and if you like, you could go BA here if you want, because it's the same thing. It's sine A times sine B is the same thing as sine B, sine A, whatever, okay? So, but however you choose to keep this all in your head, I would suggest that you keep it all in your head. Okay, from this, we could derive one more that we're going to need. Can you guess what we're going to do? Can you guess what we're going to do here?
Turn into tangent.
Yeah. And how are we going to do that?
Well, wait. Sine equals cosine times tangent?
Wait a minute. No, what I'm saying, what we want to do is I'm looking for what's tan A plus B. Well, what is tangent just by itself? Tangent is what over what?
Sine over cos.
There you go. Okay, so let's do this.
Oh, and then, oh, I see. So it's the first one over the second one.
It's just the top one over the bottom one. Okay, and I could, if I were so inclined, I could put the minus pluses in here. We'll deal with that in a second. I'd rather just do it with one of these. And so, okay, I'm not going to look up here. I'm going to do this from memory. Sine is the one that goes sine cos, sine cos. Okay. Sine is the same. Okay, so it's plus. We always start with AB, and then we go BA. All right. Cosine goes cos cos. Sine sine. Like that. AB AB. Doesn't matter. Could go BA if I were so inclined. Cosine is the opposite, so it goes like that. Now, here's the thing. I would like to get this. I could just say, there it is, and you're right, it is. But we usually want these things in terms of tangents. Oh. Knowing that tangent is sine over cosine, I'm thinking I should divide the top and the bottom by cosine of something. But I'm noticing that I have a bunch of cosines. In fact, I have two flavors of cosine. I have a cosine A and a cosine B. So what happens if I just divide the top and the bottom by 1 over both flavors of cosine? I don't know. Let's find out. Here's cosine A, cosine B. Okay, so I'm going to do that to both the top and the bottom. 1 over cosine A, cosine B. Right? Did you catch my reasoning with that? Right? Like, it's just kind of like, well, I need tangents. It needs cosines in the bottom. Yeah. There's two types of and I'm not like, it's not like this is going to do it. It actually will do it, but I don't know that. I'm just saying, well, maybe, I mean, I'll do that and we'll see what happens. So let's do the bottom for, I'll do the top first. So what happens? This entire thing jumps over and divides out that entire thing. So it's like having a sine A, sine B divided by cosine A, cosine B.
The cosine B's cancel.
The cosine B's cancel, leaving me a sine A over cosine A. Same sign. Now we have a sine B over sine B cosine A over cosine A cosine B. The cosine A's cancel, and I'm left with sine B over cosine B.
Yeah, this one.
Now this is nice. Oh, are you okay? Yeah, you're okay.
Oh, all the cosines.
Now, yeah, those cosines cancel. We just get a 1. That's cool. That's a minus, so I keep my minus. Now, sine A, sine B over cosine A, cosine B. I'll just write it like that. How about sine A divided by cosine A times sine B over cosine B.
And can turn out with tangent.
Which you'll notice, that's what?
Tan of A.
Tangent of A plus tan B. 1 is still 1. Now, that's just tangent A times tangent B. This is a useful one to memorize, but I don't have it memorized. I mean, you could get it. Yeah, you could just get it. I mean, if you need it, you could just use these and do it that way. This is a little bit easier. Instead of figuring out 1, 2, 3, 4, 5, 6, 7, 8. Actually, but you're not really figuring out all of those functions. You're figuring out 1, 2, 3, 4 functions. Here you're figuring out 1, 2, 3, 2 functions. Yeah, okay. So I guess, yeah, you might save yourself some time by writing this out, whatever. But it's good to know. So, but I don't say it's necessary to memorize these. This one, it's necessary to memorize those guys. Like, memorize them, commit them to memory for the rest of your life. But here we go, and we could play the same game where if we wanted minus b, we could plug in a minus b. Well, let's just jump to the chase here. What would that be? The a is the same. This would be a minus b. Tan of minus b is equal to what?
Negative tan.
Negative tan b. Because he's odd. The negative comes right out. Ditto here, we haven't changed this. We do change that, plug in a negative, the negative comes out. And so it'll just flip that sign and it'll flip that sign. So we could get all of this together by saying minus, we'll just make this minus and make that plus. Everybody got that? Everybody understand this notation, right? Like if I write this out, which I'm going to do right here, to make it look a little bit nicer. Tan A plus minus B is tan A. Same. Yeah, you're messing things up. 1 minus plus, right? Because now it's the opposite of whatever you've done. Tan A, tan B. Buddy. Okay? Okay. Excellent. Okay, I'm getting rid of all this. We're going to keep these guys up here. Okay, now, before we go on, let's think about this. Let's just think about the graph. Just think about this graph. I'm going to let's look at the graph of sine x plus pi over 2. That's the same as sine x, but what has happened to it?
Shifted to the left by pi over 2.
Which makes it look like what?
Cosine.
Yeah, because if sine has a peak right there at pi over 2, and we shift it left by that much, then that peak ends up right here, comes down here, it does this, and so it should be the case that this thing should just be cosine x. Let's verify it. So, okay, sine is the one that goes sine, cos, sine, cos. Sine, cos, sine, cos. Okay, sine is the same, so plus. Now, it should be x pi over 2.
Uh-oh.
And this should be pi over 2x.
And
Cosine pi over 2 is equal to what?
1. No, 0.
It's equal to 0. So this is sine x times 0
Goes
plus, what's sine of pi over 2?
1.
1 times cosine x. That's 0. That's 1. This is just plain old cosine x. That's pretty cool. Okay, you noticed that right when we first started graphing. You're like, wait, so wait, if I add this to that, it just turns it into this? Yeah, actually, yeah. And now we could utilize these to verify that. Like, yeah, it's no joke. That is what it is. If you shift this guy to the left by pi over 2, you do get cosine x right back. So, that's cool. All right, buddy. Let's get this down. All right, so your homework. You're gonna have some stuff like this. And at first, when I looked at these, there's a couple of problems you're gonna have like this. When I first looked at them, I was like, wait, what? Why are they doing this? Now I realized what they're doing. It took me a minute to figure this out. But number 6 has you compute two different things. Number 6, on part A, it says to compute sine 2 pi over 3 plus sine pi over 4. So let's do that real quick. What's sine of 2 pi over 3?
0. Wait. Oh, 2 pi over 3. I was thinking 3 pi over 2. It's negative
Pi over 3. 1, 2.
Negative root 3 over 2?
Root 3 over 2. I don't think it's negative.
Oh, no, it isn't negative. It
should be positive, because let's think about where that guy lies. Here's 1 pi over 3. Here's 2 pi over 3. Sine is the height. The height is positive. There's a bunch of other ways we could do this, but it should be root 3 over 2. Okay, so this is equal to root 3 over 2. What's sine pi over 4?
1 over root 2.
There you go. Okay. I mean, I guess we could combine these and say, well, this is the same thing as root 2 over 2, which is root 3 plus root 2 all over 2. Okay, I guess. All right. Now it tells us to compute this. Oh, does it give it to you like that? No, it doesn't. It says compute sine of 11 pi over 12. Yeah, go ahead and grab it. You could have this. Play with this. And then it even gives you the hint, which I'm totally not going to give you. It says 11 pi over 12 is 2 pi over 3 plus pi over 4. And so in other words, it's telling you to do this.
So now we can compute them added together.
And so, well, it's right up on the board. Sine is the one that goes sine cos. So, sine cos, sine cos. Sine is the same, so it's plus. And so now it's 2 pi over 3, pi over 4, pi over 4, 2 pi over 3. We just did that one. That was root 3 over 2, right?
Yeah.
Right? That's the same. Okay. Root 3 over 2. What's cosine pi over 4?
1 over root 2.
Still 1 over root 2. Plus, what's sine pi over 4?
1 over root 2.
And cosine 2 pi over 3?
1 over root 3. No. 1/2.
1/2 is a positive or negative?
Negative.
-1/2. So I guess that's the same as root 3 over 2 root 2. And this is minus 1 over 2 root 2. So I guess this is the same thing as root 3 minus 1 over 2 root 2. And if I wanted to, I could rationalize that denominator. I don't care. I think the reason why they have you do this is to show you that sine of something plus something is not equal to sine of the thing plus sine of the thing. You know what I'm saying? What we've just shown here, that number is not that number. Those are not the same number. And so it's not the case that sine x plus y equal to sine x plus sine y. That's what they're saying. They're saying this is not true. And they're trying to really hammer that home by making you brute force calculate one and then calculate the other and show you they're not equal. This is not true that this is the case. Okay? Okay, everybody got that? So that's one kind of thing you're going to do. Now remember earlier I said, as of right now, we have exact answers. We could find exact answers for any trig function where the input is n pi over 2, n pi over 3, n pi over 4, and n pi over 6.
But
now we can get some more interesting fractions. That's 11 pi over 12. We can do pi over 12. We just have to find two of these that we know that add or subtract to give you the thing that you want.
So as long as it has a pi in it?
Yeah, as long as there's, well, I don't know if we could get a pi over 7, for instance. I'm not sure if there's a way
You have to find
add,
something very creative.
it might be the case. But this, my intuition tells me we can't get like an over 7 or an over 13. But any multiples of these we could get, but anyway, that's neither here nor there. The point is, though, now we could expand a bit more. And if I tell you, find an exact value for this, you should be able to say, whoa, shoot. Can I write that as a sum or a difference of two values that I know? That's going to require some doing, but you're smart cookies and you can figure it out. So Okay. Okay, so now, here's another type of problem that you're going to see. Can I get rid of all this?
Yeah.
Oh, there went my tangent. Okay. Number 16. It says, express as a trig function of one angle. And it gives you this. I'm trying not to hold this because the guy's going to grab it. So, sine of -5 cosine 2 plus cosine 5 sine -2.
Oh, the negative can come out. Wait. You could take out the negative.
I'm thinking we should do that because, like at first, you're thinking, aha, they wrote those backwards, and so that's just backwards. But then you say, well, wait a second. Those would have to match up, and we don't have, like, an A and a B. Because if that's A, well, that's negative A. That's not the same. If that's B, well, that's negative B. That's not the same. We're going to have to get it. The first thing we have to do is get it so that whatever shows up in here is the exact same thing that's showing up in here. I think the easiest way to do that is, like you said, factor out those negatives. So that's the first thing I'm going to do. I'm going to say the sign comes out, and what happens?
It's negative sine.
Negative that cosine 2. And just because the way I have it written on the board and the way that I have it in my head, I'm just going to rewrite it with the sign on the left-hand side. You don't have to do that, but that's just how I like to do it. So the cosine is still 5. If I pull that out, then what happens?
Negative.
Is that the form that we're looking for? They're never both
You can
negative.
factor out.
You're going to have to, right? Because you can't just look at that and say, oh, it's negative that. Well, no, we'd have to factor out the negative entirely in order to put it into the form that we're given. So minus sine 5 cosine 2 plus now sine 2 cosine 5. Now, this is sine. That happens to be the same, right? And so, oh, it's plus. Be careful with if it's a minus in there, because the A and the B are going to play different roles. You see what I'm saying?
Oh.
I'll show you in just a second what I'm saying. So, the way that I have it now, though, this reduces to what? It's negative something.
Sine of 5. No, sine of 7.
Well, yeah, but let's do the step. It should
Sine of
be
5.
5 and 2. Is it plus or minus?
Plus.
Plus 5 plus 2, which is the same thing as negative sine 7, and that's it. That's what they're looking for there. Notice, like, I didn't specify whether, I mean, well, I guess I did, because I've always said that unless there's a little degree sign, you're assuming this is in radians. But it really doesn't matter.
7 radians.
Doesn't matter. So yeah, 7 radians. It's a bit more than 2 pi. But whatever. Who cares? Like, it's like we're not trying to figure it out. Like that's good enough, right? So now this would be much different, and let's just do it this way. If this were a minus, if the problem had started with a minus, then that would have made this a plus. That would have made this a minus. Now we have to stop and say, wait a second. Is this the setup I have? Because notice what's happening with the B's and the A's, right? It does matter which one comes first, right? If it's B minus A, then that's B, that's A, that's A, that's B. The way I have it written here, with a minus there, would mean, okay, if that's A, that's B, that's B, that's A, so it would have to be minus 2. And then that would be 5 minus 2 is 3. Okay, so gotta be careful with that. In this case, it's not going to matter. And that actually makes sense because A minus B, cosine A minus B, is the same thing as cosine negative B minus A, right? But cosine of a negative something is just the same thing.
So cosine of A minus B equals cosine.
And you can see that. Switch those guys around. You know, let A be X and B be Y, and now swap them around. Oh, it stays the same. It's an even function. And this formula reflects that fact. Doesn't matter what you do, which order you do it in. This one absolutely matters. This one absolutely matters. So, okay, that's that. Oh, now here's the hard part. But it's not so hard because you've done it before. You've done this kind of thing before. I do want to keep these up there. We'll keep them up there. So, I think this is problem 18. Check. Yep, 18. It tells you that both alpha, I'm not going to write this down, but both the angles alpha and beta are acute. Why would they tell you that? Well, we'll see in just a second. It tells you that alpha and beta are acute, that cosecant alpha is equal to 13/12. It tells you that cotangent, cotangent of beta is equal to 8/15. Now we want to do a bunch of stuff. A, we want to find sine alpha plus beta. B, we want to find tangent alpha plus beta. And this is where it's fun. Find which quadrant contains alpha plus beta. Right, so like think about it, right? But they're both acute. Okay, so you know that alpha and beta, if you draw them, okay, maybe that's alpha, that's perfectly good. But maybe beta's bigger, right? Maybe beta's right here. Add those together and that goes into a different quadrant.
But there will always be, it will never pass the second quadrant.
It shouldn't ever pass the second, but you should be able to discern whether it's one or two, though. Okay? And
unless one of them was negative.
Unless one of them was negative, but it tells you that they're both acute, meaning that they're both positive.
Oh.
Like they have to be. And you'll see why. Because the first thing we need to do, before we even get into this, is we're going to need to set up a couple triangles. So, if cosecant alpha, I'm just going to go ahead and do this. And this is why they're telling you they're acute. So that you can do this. There's alpha. Cosecant alpha is 13/12. So which side is 13? Which side is 12?
Well, it's hypotenuse over adjacent.
Yep.
So the hypotenuse is 13 and the adjacent is 12.
And adjacent. Adjacent?
Oh, no. Opposite.
Opposite, because cosecant is 1 over sine.
Okay.
Sine is opposite over hypotenuse, and so there we go. Now, I'm not going to go through the gory details, but this is 5. Like, you could figure that out on your own. Yeah. I did these earlier, and so... Okay, so now cotangent is 8/15, which means which side is what?
The adjacent is 8. Right, because adjacent is...
Should be, and then we'll check it when we're done, and then which one should be 15?
The opposite.
So, if I said cotangent of this, I would say, okay, tangent's opposite over adjacent, so it's the other way around. It's this one over that one. Cotangent of beta should be that over that. Yes, it is. Okay, good to go. This works out to be 17. Whew, buddy, you are so wiggly. All right, now, sine of alpha plus beta. Let's just use a formula. Sine alpha plus beta. Alpha plus beta is equal to, okay, I know that sine is the one that goes sine cos. Okay, I know that sine is the same, so if that's a plus, that's a plus. Now, we want sine alpha cosine beta, sine beta cosine alpha. Okay, well now it's all right there, isn't it? Isn't that nice? Sine alpha is what over what?
12/13.
Okay, and cosine beta is?
5/13.
Cosine beta.
Oh, beta. 8/17. 8 over 7.
See, you gotta keep this stuff straight. You gotta keep this stuff straight. So plus, sine beta is what?
15 over 17.
15/17 times cosine alpha 5/13, which you could figure out, blah, blah, blah. Now, but for this one, we're going to need to know, is this a positive number or a negative number?
Positive.
This is positive. I can tell that it's positive, okay? Now let's do the other one. We're trying to find tangent alpha plus beta. So I'm going to use this, and I'm going to say, okay, tan alpha plus beta is tan alpha plus tan beta 1 minus tan alpha tan beta. Okay, tan alpha is what?
12/5.
12/5. Plus tan beta is what?
15 over 8.
All over 1 minus tan alpha. We have them up there. That's one of the nice things about this. It's just that one. 12/5 times 15/8. Is this a positive or negative number?
I don't know.
Well, let's just look at the top. Is the top positive?
Yeah.
If the top's positive, is the bottom positive?
Is that bigger or less than?
That's the
they're
question.
Both, they're both bigger than 1, so yeah.
Both of those are bigger than 1. Multiply them together, it's bigger than 1. So 1 minus it is going to be a negative number. This will be a negative. So what quadrant are we in? So this is some angle. This is theta equals alpha plus beta. Theta has a property that when you plug it into sine, you get a positive output. So where is sine positive?
The top 2.
The top 2. Or, you could think this way. You're in quadrants 1 and in quadrants 2. That's where you're positive. But now, you're negative when you plug it into tangent. Where's tangent negative?
The second. Wait. Yeah, the second one.
And you could, there's a bunch of different ways you could do that. You could draw a tangent like this. Right? So here's quadrant 1, here's quadrant 2, here's quadrant 3, and so on and so forth. Or you could think about, the unit circle, right? Sine can only be positive when y is positive, so you're in the top half of the unit circle. Tangent is positive only in the first one and the third one, and so it must be the second one, etc., right?
Yeah.
And so, yeah. Okay. So that's how you deal with these types of problems. And I really like these types of problems. You might see them in the future. I like this type of problem too. This one's hard. But this actually takes care of everything that we need to do. So once we get through this one, you'll know how to do each one of these, in theory. Okay, let me see. Do I need that? I don't need that anymore. I'm going to get rid of that. Can I get rid of all this stuff? Any questions with this type of stuff? Every one of these types is just like this. It tells you, it gives you some setup like this, where some trig function of alpha is equal to something. Some trig function of beta is equal to something, and then it asks about either a alpha plus beta, alpha minus beta, or one of those, and it's always going to ask which quadrant does this happen. Okay. Last thing.
What's gonna be on the quiz?
Okay. Yeah. Let's go ahead and say that right now. This is going to be on the quiz. I'm going to tell you to write this down. I'm going to tell you, write this down. It should look just like this. I mean, if you, whatever. But it should not be wrong. I'm going to tell you to do that. And then, I'm going to tell you either draw 2 full periods of either sine or cosine. I'm going to tell you to draw 1 full period of tangent. Or I might tell you to draw arctan. I might tell you to draw arc cos. I might tell you to draw arc sine. What else is there? There's the triangles. I might have you draw one or both of the triangles. 30, 60, 90 and the 45, 45, 90 triangle. Basically, all those things that I've been telling you since day one that you need to commit to memory, fair game. Okay? And it's just going to be one of those because I don't want to take all day. I might have you do all the principal angles, right? Although that might take too long. But it's fair game. It should take too long. Look at this. Look how fast I'm doing this. Look how fast I'm doing this. Look at that. 2 pi over 3, right? 4, 3 pi over 4, and so on and so forth, right? Any one of those is fair game, but you're definitely going to have to write these guys down. That's going to be it, for the most part. That and one other thing that you should already have committed to memory. So that's the quiz. Now, okay, the last type of question that you're going to have, it says find solutions in the interval 0 up to pi, not including pi. This is number 56. Here's the equation for which you're finding solutions. Cosine 5t times cosine 3t is equal to 1/2 plus sine of negative 5t sine 3t. Now, this almost looks like something that's already on the board. It almost looks like something that's already on the board, right? You'll notice like the big difference here is you should be asking yourself, is this sine cosine or is it cosine cosine? Like are these the opposites are matched with each other, or are they the same that are matched with each other? In this case, they're the same ones that are matched with each other. So in order to turn this into a type of problem I've seen before, I'm going to need to get this guy over there. So I'm going to take him over, and we have cosine 5t cosine 3t minus this stuff, minus sine 5t sine 3t is equal to 1/2. Oh, look at that. Look, I didn't do that right. That should be a minus. That's a minus 5t. But now, can we just, does this apply?
Well, I have to take out the minus.
There you go, right? Now, if that one were a minus, hey, we're good. But it's not, and so we have to make it match up, right? This has to be the same as that. This is not the same as that, so we have to do it. We take out the minus, and what happens?
It's plus the whole, it's cosine of 5t times cosine of 3t plus sine of 5t.
Plus sine of positive 5t sine of 3t is equal to 1/2. Now, can I apply this?
Yes.
And so what does it equal?
Cosine of 5t minus 3t.
Ah, good. And let's just check that. And the way I like to do it is I just say, well, stop, forget everything that happened before. If you just gave me that and I were to plug it into this formula, what would I get? Well, I would say, okay, cosine is the one that goes cosine, cosine, sine, sine. Yep. The opposite now is what we have. Yep. We have a 5t and a 3t. Yep. We're good to go. I feel good about that. So what is 5t minus 3t? 2t. Let's make our lives easier. I mean, we could go and solve this, or we can make our lives easier and say, well, that's the same thing as cosine 2t. And what I suggest we do, why don't you hold it? You're like, I want to hold it, and then you drop it.
Let's hold it so you can.
Exactly. So I'm going to do this. Let theta equal 2t. Now I'm going to say, aha, I know how to deal with this guy. Cosine theta is 1/2. Now, you might be tempted to say, oh, but you're only solving it on 0 to pi, so I only need to go to pi. And pi is right there. So really, I'm only looking at 1, 0. And your intuition would fail you. So watch what's going to happen. We're finding the two values of theta, right? There should be two values of theta. Theta 2 and theta 1, for which this is true, right? What I've just graphed here is cosine theta. And we're asking, when does cosine theta give you an output of 1/2? There's two places where that happens. What's that one?
Pi over 3.
Good, right? And let's just check that. Right? 1, 2, root 3. This is pi over 3. Cosine is adjacent over hypotenuse. So cosine pi over 3 is 1/2. So this is pi over 3. That's an equal sign, by the way. That's as we're going down. That's equals, okay? And so, okay, we got one of them. What quadrant are we in over here?
The third. Wait. First, second. Fourth. Wait.
That's the only one left. 4. Yeah, we're in quadrant 4. Another way to think about it is if you're just looking at think about the unit circle, cosine is the x value. And so when is the x value positive? Well, that's when you're over here. And so you're either in quadrant 1 or 4. So here's quadrant 4. And actually, I kind of think that's a better way of doing it, because then you just say, well, so it has an angle measure of something over 3. Which pi over 3 lives down here? 1 pi over 3, 2 pi over 3, 3 pi over 3.
So 5.
5 pi over 3. Another way you could do it is say this is 6 pi over 3. Right? 2 pi is 6 pi over 3. You back it off by 1, you're at 5 pi over 3. And so, okay, the other one here, theta 2, is 5 pi over 3. And we know, now we're not restricting yet, because like I said, if you'd restricted early, you'd be in a world of hurt. We don't want to restrict at all, because if this, instead of being 2t, were like a billion t, right? You would have compressed this graph by a lot, right? And so we need to, we don't want to anticipate that we won't need all the infinitely many solutions. So what I'm going to do is do this in general and say, we've already used this. I'm going to get rid of this stuff. So you should have already memorized it. You should have it so deep in your memory that it's like, yeah, okay, shut up. So not only pi over 3 will this happen, but pi over 3 plus 2 pi plus 4 pi plus blah, 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 or minus 2 pi minus 4 pi. So in other words, when theta is equal to pi over 3 plus 2 pi n, where n is any integer. Ditto for the other one. This one will be 5 pi over 3 plus 2 pi plus 4 pi plus blah, 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 blah. So 5 pi over 3 plus 2 pi n, where n is any integer. Now, we don't care about theta. We care about what theta equals. Theta is equal to 2t. So now let's replace theta with 2t. And just to save space, I'm not going to rewrite all this. I'm just going to go, okay, we didn't care about theta, we cared about 2t. So here's 2t, here's 2t. And so we're solving for t. Let's get the t by itself. I do that, and I get, oh, stop. How about pi over 6 plus pi n? Does that work right? When I divide, I have to divide every single person in the equation by that number, so that becomes a 6. The 2 cancels, and we get just plain old pi. Ditto over here. 5 pi over 6 plus just pi n. You'll notice, it happened to be the case, since we're working on 0 up to pi, right, that interval, now if I were to add or subtract, we'd be outside of the interval, right? You take pi over 6, add a multiple of pi, obviously you're outside of that interval, right? Like, you take a positive number and add it to pi, it's bigger than pi. Ditto over here. What about negative numbers? Well, if I go in the negative direction, now I'm negative and you're past there, so we don't need to worry about it. We have both of the answers, and notice there are 2 answers. If you had just done this, right? If you prematurely said, oh, I'm only going to pi, I only need to look up to pi, and so I'm not gonna bother with this other 0, you would have completely lost out on this other solution, which is a solution to it. So be careful with that. It's much better to just wait until the very end to consider this, and just try to find all of the infinitely many solutions, right? Which really isn't that bad. You're just adding multiples of 2 pi onto something, or pi if it's tangent or cotangent, right? But you're just doing that, and then at the very end, stop and say, okay, wait a minute, I have infinitely many answers here. Which ones do we care about? Well, we only care about the ones that are right here. And so now, let's just get them all out there, and I'm imagining what they are. Okay, pi over 6 plus a pi. Oh, we're out of there. 5 pi over 6 plus a pi is out of there. What about going in the opposite direction? Subtract it off. But you can imagine that if this were instead like 7 pi, or why make it hard, 10 pi, right? Then we'd have a lot more answers, right? Like you would be able to fit a bunch of them into there. And again, that would be because this would be like taking cosine and compressing them. Instead of now, we've only compressed them by a factor of 2. If it were 10 pi, or sorry, 10t here, you would compress it by a factor of 10, and you could expect a bunch more answers. But in this case, final answers are pi over 6, 5 pi over 6, and we're done. Okay? Questions on anything? I mean, the question, we'll go over questions on homework and stuff like that Thursday, because it's a perfect day to do that.